A single under-reamed 8-meter long RCC pile, as shown in the figure, weighing 20 kN with 350 mm shaft diameter and 750 mm under-ream diameter is installed within stiff saturated Celtic clay. Under-ream shear strength is 50 kPa and addition factor is 0.3 and applicable bearing capacity factor is 9 to counteract the impact of the soil swelling on a structure constructed above. Neglecting suction and contribution of under ream to the adhesive shaft capacity, what would be the estimated ultimate tensile capacity? So it should be rounded off to nearest integer value of kilonewton. Okay. So what is the ultimate tensile capacity of the pile? So here the first thing we should know is this is under reamed pile. So let's discuss something about under reamed pile. Okay. See, this is generally a normal pile looks like this, whereas under-reamed piles have a small bulb at some depth. So this bulb will be giving extra strength to the pile in case of ultimate uh, load. In case of compression load also it will be giving extra capacity, but especially suppose if you talk about this normal pile, when you apply compression load, there can be the resistance from the surface as well as from the bottom. So when you are applying compression load, a normal pile will give the resistance at two places. One is around the surface, one is at the bottom. Suppose if the same pile is subjected to uplift load, then the resistance will come only due to the skin friction. There will not be any contact when you are applying uplift load. Because of that, you cannot get any bearing capacity. Bearing capacity cannot be in tension, right? In between two different materials, they are getting detached, so there will not be any capacity. So that's how the capacity will be reduced in case of uplift capacity in the normal piles. So whereas to increase that uplift capacity, there will be a small bulb provided. So maybe the diameter is of 2 times the diameter of the shaft. If this is the shaft, this will be the bulb. The bulb can be the diameter of the bulb can be twice that of shaft. So in general, so now when you are applying, the screen friction capacity will come because it is uplift load. So whereas the resistance will be downward direction. Okay. So now there, when you are pulling this, there will be bearing capacity on this bulb. Due to this bulb, there will be bearing capacity throughout this, right? It is giving downward force when you're up, when you're trying to pull this up. So that's where these under-reamed piles are useful. Okay. Now, so to go for the capacity calculations, so first you can have end bearing capacity plus screen friction resistance. Screen friction resistance. So total capacity will come from end bearing capacity, this one, and skin friction resistance, this one. Okay. In the normal piles, uplift capacity will come from, suppose this is compression. Okay. So in the uplift, what will happen? You will not have end bearing capacity. You will have only shaft capacity, that is due to skin friction. Okay. Skin friction, shaft capacity plus, see when you are pulling up, is the weight of this pile will also be, that is always acting downward due to gravity, so that will also resist this uplift load. So you can add weight of the pile in case of uplift capacity. So let us derive the equation to calculate the uplift capacity of the underreamed pile. See, the bearing capacity here, bearing capacity at bulb plus screen friction resistance along the shaft plus weight of the pile, Q uplift for underream. Okay, this is, so bearing capacity at bulb. See this, at bulb, downward bearing capacity, right? And screen friction resistance along the shaft plus weight of the pile, which will act W pile, which will act downward. So to draw the equation, to get the equation for that, see, first let us go for bearing capacity. See, bearing capacity, if you know the shallow foundation capacity, you can CNC plus QNQ plus of gamma B in gamma. See here, for as it is clay, this will become 0. As it is net capacity, this will become 0. So you will be left with only this. Okay, Q bearing will be, so small q. I'll refer with small q because it is in terms of pressure. Bearing capacity in terms of kPa. So that is CNC, bearing capacity. Skin friction resistance, you can calculate skin friction as alpha times cohesion or alpha times shear strength value. Okay, so alpha times cohesion. Now, if you take only in between soil particles, if you take the frictional resistance between the clay soil particles, that is C, cohesion. Because, but here it is in between two different materials. This is clay, whereas this is pile, concrete. Because of that, this will be reduced by some adhesion factor, the friction, that is alpha. So this is how you will take. So as the screen friction is along the length, along the length, what you have to do is you have to take average cohesion value along the pile. So you know this now, you know this. This C is not the average value, C at the rate bulb, because you are calculating at bulb the bearing pressure. That's why C should be at the bulb. NC value should also be taken at the bulb. Here alpha is constant, whereas C is the average overall depth. Suppose if it is, C value is varying linearly, so you have to take half of it, which is the means if it is 0 and if it is 10, you have to take 5, which is average. That's how. And another one is weight of the pile. Weight of the pile is given some value. Okay, what is the weight of the pile? 20 kilometer. So that is 20 kilometer. If you add these three, you will be getting the capacity. So let us, Q total is CNC is in terms of kPa multiplied by the bearing area, right? Bearing plus alpha C average and surface area, side surface area. You have to multiply so that you will get in terms of kilonewton. Then 20 kilonewton, that is weight. Okay. Now, what is C? C is 50 kPa given and NC is given 9. So A bearing. we have to find out, that we will find out now. Then alpha is given 0.3, Cu, as actually this is uniform Cu that is given in the question. So again average also will become 50 kPa. Then A surface we will calculate now. Then weight of the pile is given 20. So see 50, alpha is 0.3, Nc is 9. Okay, and here I'll denote, I'll just draw. Okay, see this is diameter of the bulb, that is denoted by, let us say, dB, and this is just D. Okay, this is just D. This is dB and this is D. And total length is, let us say, L, and length of the bulb is LB. So what is the total length is 8 meter and length of the bulb is 400 mm. Okay, this is 8 meter and this one is 400 mm, means 0.4 meter, right? So skin friction cannot come from this place, right? This much height you cannot get the skin friction. You will get only skin friction for this length and for this much length. Also, why it is mentioned in the question, neglecting the suction. Suction means whenever you are pulling up, there will be suction created here. Because of that, you will be getting reverse end bearing, you can say. So reverse end bearing is neglected. Also, contribution of the under ream, this is under ream, to the adhesive shaft capacity. Adhesive shaft capacity means skin friction. So you are neglecting, for this portion you are neglecting the skin friction. Okay, you have to take only this area for the skin friction, and bearing area is only this area. Okay, only this area. So you cannot take bearing area this, because you are neglecting the suction. Okay, now coming to the area of bearing. Area of bearing is what? I told you this portion is the area of bearing. How to get that area? So what is the, so total area is pi by 4 dB square. So if you take the total big circle area, cross sectional area, minus pi by 4 d. If you do this, then you will get the remaining area, annular space. Okay, that's how you can get the area on which this bearing pressure is acting. Okay, so this is pi by 4 dB square minus b square, pi by 4 dB square is 0.75, right? 0.75, 0.35, 0.75 square, 0.35 square. So what is the value? So I calculate, it is 0.34557. Okay. Then a surface. See, surface area is, you have to take only this portion. You cannot take this portion. So what is the surface area of the cylinder? Suppose if it is the cylinder, pile is nothing but cylinder. Surface area is generally pi into diameter of the pile into this, into the length. Length is how much? Total length minus bulb length. So you are deducting this much height. This much height you are deducting from the total length. So that's how you will get the area of the surface. So D is this much, D you are taking only. So what is the pi dl? L, my L is 8, LB is 0.4, right? D is 0.35. So this is equal to 8.356636 meter square. This is also meter square. So let's substitute all the values. Let's erase this. Let's substitute all these values in this equation. Q total C is 50 into 9 into A bearing 0.34557 plus 0.350, A surface 8.356636 plus 20. So I am calculating here. Calcium 4557 plus 0.3 into 50 into 8.356636 plus 20. So total it's 300 kilonewton, right? So which is the nearest integer? Nearest integer is 300.8. I have got 300.855. I have got this much. Okay, so nearest integer will be 301. So answer is D for this question. Thank you.